So, earlier today, I was sitting on the toilet when I stumbled upon this very interesting YouTube video by Wrath of Math. A very good channel, by the way. I love the guy. And you should watch the original video first. Now, um, here's my take on it. I believe I might have perhaps a better solution, even better than the in air quotes official solution video that Wrath of Math has hilariously reacted to at the end of his video. It was hilariously bad. You'll understand what I mean if you watched it. Yeah, and by the way, I just wanted to say that the biggest reason as to why I am even making this video is that I want to play the devil's advocate. I want to say that even though the official solution video was bad, I think there were still some qualities that I found legitimate. I think that it was smart for the person to use some simple numbers at first. You know, make their life easier by using simple numbers at first, like ones and twos. And that they also try to do some reverse engineering at the end, which is when they try to find a number that would divide into 76, and which turned out to be impossible at that point. So at the end, they just gave up and they put in a number that wasn't even allowed. But I still think those are correct mentalities to teach students to have when they're tackling problems of similar nature in general. Now, I still think the official solution video is unacceptable. The exercise in general is just unacceptable because if you don't have a program, even with my method I'm going to show you now in a second, it will still take too long if you don't have a program like Excel, which is what I'm going to use, or a calculator. And also, like, the exercise just does not give you some crucial information. Namely, it doesn't tell you if it has to be done in PEMDAS or not. And also, it doesn't tell you if you can use the same numbers multiple times. And also at the end here, just in general, I think any solution that comes down at the end to brute forcing is just by nature questionable. How much educational value is there if your solution is just brute forcing it at the end, especially when there's too much brute force?
I need this to be 76, and then so I know that value would have to be 76. Then I'm gonna start here. I know if I do 1 plus 13, that's gonna be 14. 14 times 2 is gonna give me 28. 28 divided by 2 is gonna give me 14. 14 plus 2 is gonna give me 16. Plus 12 is gonna give me 28. Times 1 is gonna give me 28. Minus 2 is gonna give me 26. Minus 11 will give me 15. And then I know that I need to have a 76. So I know that if I do 11, so 76, I need that to be 76 times 2. I'm gonna fill this in with 152. And then I know that to get from 15 to 152, this one would have to be 137.
Here's my solution. I have imported this question, this exercise, into just a straight sequence of arithmetic calculations in Excel. And just to prove you that it works, let's input the solution that the official solution video had given us, which is 1, 2, 2, 2, 1, 2, 137, 1 and 2, and that gives us 66. Say, like they did, they started with simple numbers. Let's just put everything to 1 at first, and let's see what we get. We get 6. Okay, where do we go from here? 6 is obviously too low. And if we use some simple logic, calculations that are at the very beginning of the sequence will for sure influence the final answer much more than any calculations at the end of the sequence, because obviously, the numbers earlier on in the sequence will get multiplied, divided, blah blah blah, more times. So if we want to make minor adjustments, we would perhaps do some modifications around the end, the latter half of the sequence. If we want to make some major modifications, we should start from the beginning, right? So let's say 6 is too low. We are too far from our target of 66. Let's go with, I don't know, 9. Let's see where that gets us. 14. Okay, let's continue. Still too far. And remember, only numbers from 1 to 9 is allowed, right? So next number, let's go with 2 because this is a multiplication. So let's be more careful here. Let's start slowly. 3, 4, 3 seems fine. And then we divide it by 1. I don't know, maybe we shouldn't touch it. Yeah. So if we just divided any number by 1, then it remains the same. Let's move on to the next one. I don't know, 2, 3. Oh, perhaps we can get 66 already here. There you go. Voila. And next, just to prove that this is not a fluke, that took us like 1 or 2 minutes. Let's get a random legit target, a new random legit target. I promise this is random. Okay, let's go. I don't know, 2, 3, 3, 4, 7, 2, 3, 4, 6. Let's say our new target is 128. Okay, and let's use the same method. Let's start with everything to 1, which should get us 6. Okay, so 6 is too far away from 128. So the first biggest number we can have is 9, takes us to 14. Then we can multiply it. Let's say the largest number is 9, too much, 8. So let's go down slowly. 6. 6 divided by 1. Let's not change that. Let's see if some of the addition and subtraction numbers can make smaller modifications. Let's go with 2, 3, 4, 5. There you go. It worked again. And just a third time. And I promise this is random. I'm doing it on the spot. Okay, let's go with 7, 8, 2, 3, 4, 7, 1, 2, 3. I don't know. 232. Let's do 232 next. So everything to 1, just to simplify as much as possible, right? We have 6. 6 is too far from 232. Let's put 9 as our first answer. And then we probably have to multiply by 9 because 232 is so much larger than what we have so far. We don't divide it by anything because we are still too small. That's what she said. And I don't know, the next number, it's an addition, so we can probably make it very high. Yeah, it wouldn't affect our answer by too much. Then it's times again. Let's go back to 1 here because this is a multiplication, so it will probably influence our answer by a lot. So let's not touch this one for now. Let's do the next multiplication first. Let's go times 2. Woof! That's too big. So we can maybe lower this one down to 8, 7, 6. Okay, let's go 5. 5. Are we done here? No, probably not, because this will get multiplied by 2. And this is not a multiple of 2. But let's see anyways. 3, 4, 5. And we are off by 1. But that is, no, it's not adjustable because this is the first number. Oh, it's a multiple of 10. Okay, where can we add 1? I don't know. Let's do here 2. Ah, sorry. Oh, we here is already the smallest number possible. Okay, -1 here. That might not work, but I'm not good at math. Sorry, 2. Maybe it works. There you go. Yeah, and the reason why I went down here is because look at here, -1 divided by it just remains the same, right? So the last number here, if we ignore this part, is just a minor addition. So that one, and up until here, they're all just additions. They don't get multiplied or divided. So you can probably adjust, like I said earlier, the very latter sequences of operations without modifying your final answer by too much. So you can do your final micro adjustments with the numbers over here. And the reason why I did the quote unquote micro adjustments in the previous examples early on is because I didn't change anything down here yet. I hadn't changed anything down here yet. Anyways, try this method out. Tell me if it's foolproof. Like they all took me what, 2-3 minutes to find the target value. So I believe this kind of works. And again, I want to give props to the official solution video because this is what inspired me. Like start with simple numbers and do some reverse engineering basically. Yeah, and this is what I did and it works. Okay, to conclude, is this now really the worst math problem ever? I don't think so. I think there is lesson to be learned. If the exercise was, let's say, the question was formed more comprehensively, that it tells you that it doesn't have to be PEMDAS and that you can use numbers multiple times, and that you're also allowed to use a program such as Excel. In my opinion, if you can do this kind of math mentally just as fast, then good for you. I am not as good. But that's my opinion, that's my video. Thank you for watching.